Thank you, Chrissy, and thanks to the organisers for having us here today. Yeah, what a fantastic breakfast that was this morning, and thank you again to Amanda for a wonderful speech, and for Joe for putting that on for us this morning. That was fantastic. I'd like to start with our acknowledgement to the Wonnamurra people, the traditional owners of the lands that we work on up in Julia Creek, and pay our respects to their ancestors and of course to their descendants who continue the cultural and spiritual connections to country out there. We recognise their valuable contribution to both Australia and the global society. Okay, let's get going. There's our usual disclaimer. This will be available on our website and on ASX platform, probably making some forward-looking statements today, so you can look at that at your leisure. So QEM is looking to develop a globally significant and regionally significant project, both globally significant in its vanadium content and locally and regionally significant because of its the fuel oil that we're looking to produce out there as well. Sorry, just go back one. Yeah, so we're looking at a multi-commodity project here, vanadium as well as transport fuels, and we're doing this in a very unique fashion that we're going to use renewable energy to produce green hydrogen and use that in the processing that we're going to do out there at Julia Creek. This is a large project, it's globally significant in scale. And of course, you can have a great resource in a great location, but of course, you need a great board to bring that about, and we certainly have that. So, Tim Wall, our chairman, who's joined us here this morning, Tim's the ex-MD of BP's refinery at Bulwer, Instatech Pivot, global manager there for manufacturing. We also have Daniel Harris on our board, and Daniel is probably one of the foremost experts in vanadium globally. He's one of the heads of US Vanadium in Arkansas. They make the highest spec vanadium projects in the world, products, I should say, in the world. And Daniel was also the vice president of Evraz and ran their vanadium division for quite some time in Moscow. Myself as the founder, and we went out there and discovered this project in 2014 and first drilling in 15. And David Fitch was one of my co-founders and continues to be a great supporter of the company. Quick corporate snapshot. This will change a little bit. As some of you may be aware, we've just come out of a trading halt yesterday where we raised another $2.75 million with the help of Viriathus and Spark Plus, who are here today as well. So quite a good effort in this pretty tight market. A little bit oversubscribed, so we're quite happy with that. And I think we had a bit of a bump yesterday as well of about 11%, so that was handy. We've got a very small market cap, and that's important when you understand the size of this opportunity, and hopefully that'll be the takeaway from today. Very tightly held company, directors and friends and associates and high net worths who had invested in this project earlier maintain their position and tend to hold their holdings for quite some time. So the top 20 still holds close to 70% of the company. And as a board, we've never sold a share since we started. So, where are we? We're up here in Julia Creek. So if we up here, you can see the three main projects that are out here in Julia Creek at the moment. We're the Julia Creek project. There's St Elmo's to our north and Richmond to our northeast. And this is some of the other projects that are over in Western Australia. Now, there's a distinction between those two areas. One is magnetite in Western Australia, and that's a hard rock material. And where we are in Queensland, where you can see that green area, that used to be an inland sea. And we're from a sedimentary deposit, so there's a distinction there. And we've just come into the Geological Society down in Canberra, Australian Geoservices, and we've found out that we are now number 2 in the world for global resource of vanadium, and 31% of it is in Australia. And interestingly, we haven't developed any of these projects yet, but there's a number of them underway, including us. So we have a large resource. This is a massive resource. This is 2.5 billion tonnes of vanadium at 0.3%. And along with that comes about 700 million barrels of oil in situ. And it's in the oil shale. You can see that core sample that's on the screen there. It's a black material. It's only about 60 metres deep. And we take that material out, we extract the oil, and then that allows us to liberate the vanadium. I'll explain a bit more of that in a moment. So location-wise, we are right on the road and rail of the heavy rail from Townsville to Mount Isa, as well as the highway, the Flinders Highway, and only about 6 kilometres out to the edge of our tenement to the town of Julia Creek that you can see just up here. Has its own airport, and this main pit that you can see here, that's 30 years of mining in that first pit shell. But if you extend this out to the boundaries of where we are in this inferred resource, that's about 100 years of mining. So this is a long, multi-generational project. Now, what is critical? What is vanadium? Well, it's a critical mineral. It's on the list, and very significantly, because it's been primarily used in steel strengthening, and it's still quite the largest part of the market. So anything that needs high tensile steels, tooling, rail, shipping, needs a lot of vanadium in that metal, and that's been where most of the vanadium has gone globally. It also adds significantly to the strength of steel. In fact, Henry Ford was the first to use it in the Model Ts. In fact, he had the only vanadium mine in the world in Peru from about 1901 to 1952. Now, anything that goes supersonic speed needs quite a good deal of vanadium in there, and about 20% plus in the alloys. And that's why Mr. Musk, with his Falcon Heavy rocket there, can go a lot further with a lot more payload, because the width of the steel that's used in those rockets is actually 1/7 of what it was to send the man to the moon, and that's because of the amount of vanadium that's in that material. It's also in catalysts, it's in for sulfuric acid, it's in oil production, it's in smart glass, it's the tinting on your glasses. So these are all well-established industries, and that's where most of the vanadium has gone. But the real interesting part of where we see vanadium going in the future is in vanadium redox flow batteries. Now, these are large liquid batteries suitable for the grid, fantastic in Australian conditions, sub-zero temperatures up to 60 plus temperature range. They never get a battery memory, they last over 30 years, they're fully recyclable. In fact, the electrolyte that's produced to run these batteries, you can take it out of a system after 30 years, put it straight into another one, never degrades. It's exactly the same as it was. And interestingly, you can charge and discharge, and that's important when you're looking at grid stabilisation. So when you get surges in your grid, we usually go to gas peaker plants, which are quite expensive. These work in that situation very well. And of course, to go off grid, they're long duration storage batteries. So anything excess of 4 hours is regarded as long duration. These are more your 8 to 12 hours at the moment, and they're improving all the time. So as I mentioned, we've got about 31% of the global resource. Where you see the energy storage there being 4% of the market, that is currently true. There's about 200 projects globally getting up at the moment. There's a large one down in South Australia being constructed as we speak at Yadamulka. But that dynamic is going to change very quickly, because we'll need 100% of what's currently mined and currently in the market for vanadium just for the batteries. That's how significant the change is going to be in the energy transition. That's the growth forecast for vanadium batteries. They're growing at about 41% year on year. And the fuel side of things, well, it's now a security issue in Australia. We have over 93% of our imports come from overseas. I think it's 89% for diesel and 79% for imported aviation fuel, which is interesting given that we've just spent about $70 billion on jets. So how are we going to do all this? Well, in this process, it's a shallow open cut mine. And what we do is we extract that ore that you saw earlier, we crush it up, we put it through a supercritical phase, which is, which is this piece here. And this is what we've spent a lot of time, effort and money on over the last few years, is developing this process. It's a closed loop supercritical process that uses a hydrogen donor solvent. So we've had to develop quite a large renewable project because of the amount of green hydrogen that we'll be producing for this process. So we use it we turn it into a solvent, and that solvent then extracts the raw oil. That raw oil comes down and is secondarily hydrotreated by further hydrogen to get us to a diesel product. But the beauty of this is this hydrogen donor solvent actually does expand the hydrocarbon chain. So you saw earlier what our oil resource was. We can get about 1.8 times of what that says is in the ground, and that's really because the way they measure it is quite dated. But the other major advantage for us there is that we then end up with the vanadium remaining in the solid material, and it has an upgrading effect. So once you've taken out the moisture and the oil and the other various pieces, you're left with a concentrate on the deck, free of mining costs, so there's a competitive advantage there. And then we extract the vanadium. We're looking at about 10,000 tonnes a day, which would be about, at the moment it's about 8% of global output, but as I said, with 100% growth in the renewable space, it'll go up, it'll drop down to around about 4 or 5%, I'd suggest. Now, we built a pilot plant to test these theories. We spent a few years in the lab, and then we thought we'd take this to the next level of scale. Now, this is hundreds of times larger than we were doing in the laboratory, of course, and this pilot plant actually works and does what we asked it to do. So we're getting those sorts of yields on the oil, and that'll, as I say, frees us up to extract the vanadium. Now, we are in quite a remote location, so if you were here earlier and heard Amanda speaking about power in remote regions, it's a bit of a challenge. But we've been very lucky that the government has seen this opportunity and has developed or is bringing to bear, I should say, the Copper String 2 network, or the Copper String 2032 as it's known now. And that was to bring power out to the region, but of course you needed some more generation. So we had to spend some time and effort to put up, or design, I should say, a 1 gigawatt power project. So this is a wind and solar project. This is something that we've got some global developers interested in at the moment, and we've got some non-binding offers to do that project. But the real key for this, and if anyone's developing a project from a clean sheet of paper, the gear that we put out there, which is a 160 metre met mast, which measures the atmospherics, it measures the wind speed and the solar radiation at that height, because that's the height of the turbines. And the other piece of equipment was the solar equipment, which allows those two pieces to speak together. Why it's important, you need 12 months of that live data to go to a financial decision on a project of that size. We're working on some water solutions. We take a common user approach with a lot of the other vanadium proponents out there, and we're hoping to get a water pipeline built for the project. We've got some great support from government. The government is building a $75 million facility in Townsville, which is called the Queensland Resources Common User Facility. Again, is for the vanadium users to go in there and show that they can produce vanadium at that next level of scale, at the demonstration scale. And that was originally 10 million and up to 75 million, so strong support there. Now we're doing a little bit of recycling work in the interim as part of the circular economy. We're taking the waste stream of sulfuric acid production here in Queensland from Sun Metals initially and others to follow. And we extract the vanadium catalyst that's used in the acid production. We can extract the vanadium back out of that, recycle that back and use that for battery electrolyte, and we can get about a 99.6% purity from that material. And that's something we will hope to do at the Queensland facility. So obviously our mission is to do this as cleanly and as safely as possible, particularly when you're talking about fuel production. We are using a great deal of renewable energy, and as I say, that'll go to producing the hydrogen that we need. So it's very, very clean. ESG is obviously a very strong component of what we do, and we use Social Sweden. I see they're here at the conference here this week as well, talking about that format, and I encourage everyone to have a look at that. And here we are out with the Premier at the announcement of Copper String, and when we're announcing our deal with Sun Metals. So we think we've got the right project at the right time. It's a critical minerals project in essence, and I think you'll see the size of the opportunity here compared to our current market cap is really leaves us with a lot of growth opportunity in front of us. So thank you.